Welcome to our prerequisites. The first one is solving equations and inequalities. We're going to start with a little bit of notes and do some examples as we go. So in order to solve an equation, you must isolate the variable. In order to isolate it, we use inverse operations to solve. We're going to use a bunch of algebraic properties to remain organized while we do it. So let's look at these algebraic properties. First, you have the commutative property, which just states that in addition, you can add numbers in any order without changing the result. So a plus b equals b plus a. You can do it with multiplication as well, a times b equals b times a. The associative property, which allows you to group numbers in a sum and still get the same answer. And when we group things, we typically use parentheses. You can also do it with multiplication. Okay, the identity property states that if you add 0, it's still itself. And if you multiply by 1, it's still itself. The distributive property allows you to distribute using multiplication to all terms inside the parentheses. Right? A times the quantity b plus c equals a times b plus a times c. Combine like terms allows us to simplify an expression by exactly that, combining like terms. So here x plus 2x are the like terms. We can combine those to make 3x. And then finally we have the properties of equality. These properties are the ones that we actually use to isolate the variable, to solve an equation. And that's addition, subtraction, multiplication, and division properties of equality. The properties of equality part just tell you whatever you do to one side of an equation, you have to do to the other side. Okay, so that's the properties of equality. So let's actually look at this in action. So our first example is literal equations. And that's just equations where everything is a variable. So we're just looking at the very basic, the bare bones of what solving an equation is. So here our question is u equals a times k minus b. And we're solving for a. So to get a by itself, we have to use the addition property of equality to get rid of negative b. We're going to add b to both sides. So we end up with u plus b equals a times k. In order to get a by itself, we're going to divide on both sides, the division property. We're going to divide by k. So this ends up being u plus b, all of that divided by k. That equals a, and if you need to, you can use the symmetric property just to switch which side the a is on, however you want it to look like. Okay, so a equals u plus b divided by k. Okay, so let's look at this with actual numbers. Here this time we have x divided by 10 plus 6 equals 8. So we need to get rid of the plus 6 first. So we subtract 6 from both sides and get 2. To get rid of divide by 10, we multiply by 10 and we get x equals 20. Okay, another example of this is a little bit more difficult. We have some distribution in there first, so we have to distribute the negative 1 in front of that parentheses. So we end up with negative x plus 6, and we bring down our minus 7 still. Now we combine like terms. 6 and negative 7 make negative 1. And if we want to get x on one side of the equation, we're going to add x to both sides, and the x actually cancels, leaving us negative 1 equals negative 1. That is a true statement, therefore the answer is infinite solutions. There are infinitely many solutions for this equation. Okay, so that's solving equations. Now let's look at what proportions are. Proportion is just two ratios set equal, meaning it's an equation setting two fractions equal. To solve a proportion, you must cross multiply, and the resulting equation is called the cross products. So here a over b equals c over d. Our cross product is a times d, which equals b times c. Okay, so let's see this with numbers. Here we have 8 over 9 equals x over x plus 8. To cross multiply, we distribute the 8 onto the x plus 8, and then we multiply 9 times x. So we get 8x plus 64 equals 9x. We need to get x on one side of the equation, so we subtract 8x from both sides to get 1x. 1x equals 64. Again, if you need to, you can use the symmetric property to flip that. X equals 64. Okay, so that's proportions, and you can do this many ways with proportions. The last set I want to go over is solving inequalities. Solving inequalities is done in the same way as equations. The only difference here is if you multiply or divide by a negative number, then the inequality sign changes. And to graph an inequality on a number line, you're going to use the inequality sign to determine the direction of which the line goes. and you use a closed dot if it can be equal, and an open dot if it cannot be equal. So here our example is x is greater than 4. The greater than part tells us we're going to go to the right, and the fact that it's not equal tells us it's going to be an open dot. Okay, so let's see this last one in action. Here we have x minus 4 over 8 is greater than or equal to negative 1. To get the x minus 4 by itself, we multiply by 8 on both sides. So we get x minus 4 is greater than or equal to negative 8. We're going to add 4 to both sides. And we get that x is greater than or equal to negative 4. The fact that it's x is greater than or equal to tells us we're going to go to the right. And the fact that it can be equal tells us we're going to put a closed dot over negative 4 and we're going to go to the right. That's all solving equations and inequalities. Good luck on the practice and application.